Chapter 7, the cost of production function. So chapter 7, we studied cost function. Outline of this chapter is like this. Subsection number 1, measuring the cost, which costs matter. So conceptual part. Section 2, cost in short run. And section 3, cost in the long run. Section 4, long run versus short run cost. 5, production risk to output, economies of scope. And section 6, dynamic changes. Section 7, some mathematical one. So in section 7, we can derive labor demand curve, labor demand or optimal capital demand, right? Solving cost minimization problem mathematically. This section is quite similar to the process. We find optimal demand for good 1 and good 2, right? And the process of utility maximization. Okay? So sometimes I'll ask you to derive some optimal labor demand and optimal capital demand and minimize cost from those two. Okay? Okay. Economic cost versus accounting cost. Section 1, measuring cost, which costs matter. Accounting cost is actual expenses plus depreciation charges for capital equipment. So that is accounting cost. And economic cost is different from accounting cost, isn't it? Cost to a firm of utilizing economic factors in production. So actually economic cost is equal to opportunity cost. Opportunity cost associated with opportunity cost foregone when a firm's resources are not put to their best alternative use. Okay, so alternative use, that is opportunity cost or economic cost. The concept of opportunity cost is particularly useful in situations where alternatives that are foregone do not reflect monetary outlays, right? Monetary outlays. So we consider opportunity cost or economic cost include the cost not accompanied by monetary outlays, right? Also, the other concept is sunk cost. Sunk cost is expenditure that has been made and cannot be recovered, right? After expenditure, we cannot recover at all. That is sunk cost. Because a sunk cost cannot be recovered, it should not influence the firm's decision. So sunk cost is not influence on economic decision at all, because anyway, not recovered. For example, if a specialized equipment for a plant cannot be converted for alternative use, right? Then the expenditure on this equipment is a sunk cost. That is sunk cost, not recovered. Because it has no alternative use, its opportunity cost is equal to 0. Sunk cost, opportunity cost of sunk cost is 0, right? Thus, it should not be included as part of a firm's economic cost. A prospective sunk cost is an investment. Here, the firm must decide whether that investment in specialized equipment is economical. Next slide. Example 7.1, choosing the location for new law school building. So that is United States example, Northwestern University, located in suburban area of Chicago city, right? But this university has some office in urban region, city region. So blah, blah, blah. Anyway, they want to use some buildings in Chicago city. And lots of people believe that that is no cost because that is pertained by Northwestern University. So no outlays of expenditure at all. But economics thinking is quite different, isn't it? Anyway, if that office building in the Chicago is lent to others, they can receive some money. So that is, I'm sorry, that money. That means opportunity cost is quite expensive. Okay, now we go next section. Fixed costs and variable costs. Total cost, total economic cost of production, consisting of fixed and variable costs in the short run, isn't it? Fixed cost does not vary with the level of output, and that can be eliminated only by shutting down. It doesn't matter you produce 10 pence of pizza or 100 pence of pizza in the short run. Anyway, you have to pay some rents for capital over. Okay, that is fixed cost. Variable cost that varies as output varies. You produce more pizza, then you can hire more labor in the short run, right? So labor cost is variable cost. It's not possible to cook more pizza without increasing labor employment. Fixed cost does not vary with the level of output. It must be paid, for example, rental cost of capital, even if there is no output, no production of output. The only way that a firm can eliminate its fixed cost is by shutting down or leaving out of this business, going out of this business. Shutting down doesn't necessarily mean going out of business. By reducing the output of the factory to zero, the company could eliminate the cost of raw materials and much of the labor, simply save variable costs. But it would still incur the fixed costs of paying the factories, managers, security guards, and the ongoing maintenance, rental rate of lands, buildings, or capital over, for example. The only way to eliminate those fixed costs would be to close the door, or going out of business, turn off the electricity, and perhaps even set up or scrap the machinery. Fixed or variable? How do we know which costs are fixed and which are variable? Over a very short time horizon, in the very short run, say a few months, most costs are fixed. Most costs are fixed in the very short run. Over such a short period, a firm is usually obligated to pay for contracted shipments of materials, for example. Over a very long time horizon, say 10 years, nearly all costs are variable. Workers and managers can be laid off, and much of the machinery can be sold off or not replaced as it becomes obsolete and is scrapped. Okay, in the time horizon matter. In the very short run, everything is fixed cost, but in the very long run, everything is a variable cost. Next slide, fixed versus sunk cost. Fixed cost can be avoided if the firm shut down a plant or go out of business. Shut down a plant or go out of business. Then fixed costs can be avoided. Sunk costs, on the other hand, are costs that have been incurred and cannot be recovered. We already studied this. In that sense, two things are different. Fixed costs affect a firm's decision, right? Fixed costs affect influence on the firm's economic decision looking forward, whereas sunk costs do not influence on the decision at all. Anyway, loss. Okay? So fixed costs that are high relative to revenue and cannot be reduced might lead a firm to shut down. Eliminating those fixed costs and earning zero profit might be better than incurring ongoing losses. Incurring a high sunk cost might later turn out to be a bad decision, but the expenditure is gone and cannot be recovered by shutting down. Anyway, the expenditure is gone. A prospective sunk cost is different and does affect firm's decision looking forward. Okay? So, slide number 9. Amortizing sunk costs. So amortize means So 감가상각 in Korea, right? Amortization, policy of treating one-time expenditure as an annual cost spread over some numbers of years. So we said 감가상각 처리, right? Amortize large capital expenditures and treating them as ongoing fixed costs can simplify the economic analysis of a firm's operation. As you will see, treating capital expenditures this way can make it easier to understand the trade-off that a firm faces in the use of labor versus capital. When distinguishing some costs from fixed costs does not become essential to economic analysis. Okay? Not essential. Slide 10, example of sunk, fixed, and variable costs, computers, software, and pizza. It is important to understand the characteristics of a production cost and to be able to identify which costs are fixed, which are variable, and which are sunk. Computer industry, think about computers. Because computers are very similar, competition is intense, and the profitability depends on the ability to keep costs down. Most important are the cost of components and labor. So computer industry where variable cost matter. Variable cost is important. So variable cost industry in some. Think about software industry. A software firm will spend a large amount of money, lump sum money, to develop a new application. The company can recoup its investments by selling as many copies of the program as possible. And large amount of some money, right, expenditure is not recovered anyway, right? So software is sunk cost industry, featured by sunk cost. Okay? How about pizza? For the pizzeria, sunk costs are fairly low because, for example, capital oven can be resold if the pizzeria goes out of business. Okay? So capital oven can be sold to a hamburger restaurant. Anyway, so this can be used, have capital star, have alternative use. Variable costs are very low. Mainly the ingredients of pizza and perhaps wages for workers to produce and deliver pizzas. So we know that pizza is the industry featured by variable industry. I'm sorry, capital industry. Capital is really important in pizza business. Okay? Finally, this textbook. Most of the costs are sunk. The opportunity cost of author's time spent writing the book and the cost of publisher for copy editing, typesetting, and the proofing. As with computer software, textbook production costs need a little connection to the price you paid for the book. A little joke about anyway, this is also featured by sunk cost industry. Okay? And next slide. Marginal average cost. So we already studied this kind of thing in Chang-Soo Introduction to Economics book. That is Y variable. Production of output, 1 unit, 2 units, 3 units, like this. And fixed cost is constant numbers, right? For example, it doesn't vary at all. It doesn't matter. You produce no output or 11 output. Every time, fixed cost fixed at $50. And variable cost increase and increase and increase. The total cost is variable cost plus fixed cost. Then, what is marginal cost? Marginal cost is change in total cost or change in variable cost. Okay? So change in variable cost, when you moving here to here, 72, you produce 1 to 2. Then 78 minus 50. So 28, isn't it? That is marginal cost. And total cost, or change in total cost, 128 minus 100. Anyway, same. So marginal cost, when production function is, for example, this kind of thing. Marginal cost is that, in the short run, total cost anyway, total cost is WL over RK, right? Marginal cost is change in variable cost over change in Q, right? Or this is the same to change in total cost over change in Q, right? So marginal cost is change in variable cost over change in Q, or change in total cost over change in Q. Average total cost. Average total cost is total cost divided by Q, right? Average fixed cost is equal to total fixed cost divided by Q, right? And average variable cost is equal to variable cost divided by Q, right? So from here, in earlier graph, for example, average fixed cost, 100, when you produce 1 unit, fixed cost is 50, so 50 divided by 1, so 50, right? And when you produce 2, fixed cost is $50 again, divided by Q2, so 25 like this. So average fixed cost decreasing as you produce more. Average variable cost is this one, variable cost divided by Q, like this. So average total cost is equal to, basically, this one is equal to Q. Total cost is fixed cost plus variable cost, isn't it? That means FCQ plus VCQ. So this one is equal to, average fixed cost plus average variable cost. Okay? The determinants of short-term cost. The change in variable cost is the per unit cost of extra labor, W times amount of extra labor needs to produce extra unit, right? So, so variable cost is this one, isn't it? WL, right? WL. When the market is perfectly competitive, wage rate is same, constant number. You hire 2 labor or 10 labor anyway, wage rate is same, so WL. Then now think about marginal cost. Is change in variable cost divided by change in Q, isn't it? Right? Then we can say change in variable cost is the change in WL over change in Q. Okay, and the wage rate is just constant number. So rewriting this, W change in L over change in Q. Right? And we know this one is the reciprocal value of marginal product of labor, isn't it? So rewriting W over MPL. Right? That is explained here. Diminishing marginal returns and marginal cost. Diminishing marginal returns in the earlier chapters, right, means that the marginal product of labor declines as the quantity of labor employment increases, right? So diminishing marginal returns and increasing marginal cost is the other side of same coin, simply talking, right? That is marginal cost, isn't it? Marginal cost. In sum, marginal cost is equal to this one, right? So marginal product of labor, marginal cost. So diminishing marginal product of labor means increasing marginal cost, right? In production side, we're talking about diminishing marginal product of labor, right? Because of this, marginal cost increase as you produce more. The other side of same coin. As a result, when there is diminishing marginal returns, marginal cost will increase as output increase. Okay? So the shape of the cost curve. Cost curve for a firm. In A, total cost, TC is vertical sum of fixed cost and variable cost. Right? Fixed cost and that is variable cost. Graphically. For example, Q. Y variable is total cost. Fixed cost is constant, right? And variable cost is, for example, shaped like this, right? I'd like to more flatter than this. How can I say? Oh, difficult, isn't it? So like this, right? That is variable cost, that is fixed cost. Then total cost is variable cost plus fixed cost. So shaped like this. Oh, that's very difficult, isn't it? Right? That is total cost curve shaped like this. In figure 7.1. Right? From here, also from this graph, we can calculate large of cost, right? So from here, now think about our earlier explanation. Marginal cost maximize at this point, right? Minimize at, how can I say? Marginal cost is minimized near here, isn't it? Right? Slope decrease, increase with decreasing rate, and minimized here and increase again, right? So marginal cost minimize at this point. Marginal cost shaped like this, right? And average cost, average total cost is just average total cost at this point. You draw straight line to the origin point and make triangle. Tangent of this triangle is average cost, and average cost minimize at this point, right? So average cost minimize at this point. Average total cost minimize at this point. At this point, average total cost equal to marginal cost, right? This point, origin to this point, this triangle. Gradient of this triangle is average cost, minimized, right? Now think about like this, right? And at this, also think about marginal cost at this time. Draw a straight line tangent at the point and make triangle using 2 points on this straight line. That is marginal cost. And we know that that straight line is coincides with the straight line of variable cost calculation, isn't it? So same. So marginal cost, average cost shaped like this. Right? Above total, average total cost is the sum of average variable cost and average fixed cost. Actually, that average total cost is sum of average variable cost and some this kind of average fixed cost and average variable cost. Important thing is here, the gap between the two, average total cost and average cost. The gap decrease and decrease and decrease as you produce more Q. Why? Average fixed cost decrease and decrease and decrease. The average marginal relations. Marginal and average cost are another example of average marginal relationship described in chapter 6. Right? So I already explained the marginal product of labor and average relationship between average product of labor. So graphical some explanation. Because average total cost is sum of average variable cost and average fixed cost, and the AFC curve declines everywhere. The vertical distance between A to C, average total cost and average variable cost curves decrease as output increase. I already explained. Next slide, number 16. The total cost is a flow. The firm produces a certain number of units per year. Thus, its total cost is flow. For example, some number of dollars per day. For simplicity, we will often drop the time reference and refer to total cost in dollars and output in units. Knowledge of short-term cost is particularly important for firms that operate in an environment in which demand conditions fluctuate considerably. If the firm is currently producing at a level of output at which marginal cost is sharply increasing, and if demand may increase in the future, management might want to expand production capacity to avoid higher costs. Example of the shown cost of aluminum smelting. The production of aluminum begins with mining of bauxite. The process is used to separate the oxygen atoms from aluminum oxide molecules, called smelting. What is smelting in Korean? Yonghae? Anyway, this is the most costly step in producing aluminum. Right? The expenditure on smelting plant, although substantial, is a sunk cost and can be ignored. Fixed costs are relatively small and can also be ignored. So then just variable costs left. So look at this. When you're producing less than or equal to 600 units a day, then the cost consists of this one: electricity cost, alumina, raw material, plant power and fuel. Everything is a variable cost. In total, 820. Also, a per ton cost that increase when per ton cost that output exceeds 600 tons a day. Anyway, labor, maintenance, price. Anyway, this is also labor cost, right? So in total of this one is $302. So this total variable cost, average cost is $820 plus $320. So $1,140. Okay? But when you produce more than 600, this one same, right? This variable cost of these components are same, $820. But this one, labor maintenance price, this one increase, right? When you produce more than 600. Anyway, this is a variable cost, but increase, higher, become higher when you produce more. So like this. This is this one. So when you produce more than 600 units, total cost is average 820 plus 1300. Okay? Different, isn't it? So when you produce less than 600, so total variable cost. Anyway, there is no fixed cost or some cost here. Total cost is equal to 820 plus 320. So this one, right? But if you produce more than 600, total variable cost is 8 plus 480. So 1300. Okay? Cost is different. So for output Q, now in this case, you can calculate total variable cost, right? Total variable cost. In this case, okay, so in that case, this is wrong. Not total variable cost, average variable cost, average total variable cost, because this is a per unit cost. Everything is per unit cost, right? So average cost. So similarly, this is average variable cost is like this. Then next slide, for an output Q up to 600 tons per day, total variable cost is, then average variable cost is this one. Then total variable cost when production is less than 600, then like this, because average variable cost like this, right? And no cost, no fixed cost, no sunk cost. So total variable cost is like this. Similarly, when Q is higher than 600, total variable cost is like this, right? So, I'm sorry, That is not true. Anyway, like this. And for an output Q up to 600 tons per day, total variable cost is like this. So marginal cost and average cost, total cost are constant and this, right? Total variable cost or total cost is like this. Then marginal cost, average variable cost equal to like this when Q is up to 600 tons. If we increase production beyond 600 tons per day by means of a third shift, the marginal cost of labor, maintenance, and freight increase from 320 to 448 tons, which causes marginal cost as a whole to increase from here to here. 1140 and 13,000 per ton. Average cost is this one, right? What happens to average variable cost when output greater than 600? Then we can calculate when Q is greater than 600, total variable cost. We can calculate total variable cost. Okay? That is this one. Total variable cost up to 600, total variable cost is this one, right? So total variable cost is multiplied by 600, right? So Q greater than 600, right? This means total variable cost consists of two parts. First part is following this rule, right? Q equal higher than 600, then following this rule. So if now Q equal higher than 600, up to 600, total variable cost is 1. And remaining part, remaining production is this one. When Q equal higher than 600, average variable cost or marginal cost is this one, right? So this one is Q minus 600. That is total variable cost when Q greater than 600, right? Up to 600, this one multiplied by Q plus Q greater than 600, marginal and average cost is this one, right? So calculating this one, 1,300 Q minus 96,000, like this. That is total variable cost when Q greater than 600. Then average variable cost is equal to variable cost divided by Q. So this one divided by Q. So this one, Q disappeared, and this one divided by Q. That is average variable cost. Okay? So look at the figure 7.2. When Q equal or less 600, average variable cost or marginal variable cost is 1,140, right? And Q greater than 600, marginal cost is 13,000, 1,300, like this. So average variable cost is up to 600, this one, but Q equal greater than 600, this one. This one is calculated from here. Next slide is the user cost of capital. User cost of capital is annual cost of owning and using a capital asset equal to economic depreciation plus foregone interest, right? Depreciation plus foregone interest. User cost of capital is equal to economic depreciation plus interest rate. right? Interest rate, interest, right? Interest. This user cost of capital, right? So interest rate multiplied by value of capital stock like this, okay? Then we can also express the user cost of capital as a rate per capital, rate per dollar of capital, rate dollar of capital. Then we can say that at the rate, we said R, then depreciation divided by K, so depreciation rate. So we usually say D plus interest rate, I, like this, right? R is depreciation rate plus interest rate. Cost minimizing input choice. We now turn to fundamental problem that all firms face, how to select input to produce a given output of minimum cost. For simplicity, we will work with two variable input, labor and capital, right? So now think about cost in two-factor model. Cost, total cost is equal to labor cost plus capital cost, right? Cost, right? So cost minimization side, minimization of total cost subject to Q equals something unique, right? That is cost minimization problem. So that is cost minimizing input choice, labor and capital choice, input mix to produce given unit of output with the cheapest cost. Okay? In this way, L star and K star is decided. Okay? And our slide before that explain what is R, right? Rental rate of capital stock. So before explaining rental rate of capital stock, first we explain user cost of capital at rate like this. The price of capital. Now think about the price of capital. In the long run, the firm can adjust the amount of capital it used. The firm must decide prospectively how much capital to obtain. In order to compare the firm's expenditure on capital with its ongoing cost of labor, we want to express this capital expenditure as flow in dollars per year. To do this, we must amortize the expenditure by spreading it over a lifetime of the capital. And we must also account for the foregone interest that the firm could have earned by investing the money as well. The price of capital is its user cost, right? The price of capital is its user cost at rate. So R equal T plus I. So price of capital stock is equal to user cost at rate, right? And finally, now think about rental rate of capital stock. Rental rate of capital stock. Rental rate of capital stock. Okay? Rental rate, the cost per year of renting 1 unit of capital. If the capital market is competitive, the rental rate should be equal to the user cost R, right? Rental rate. So now you run pizza restaurant, you rent some capital oven from others. The price of that is rental rate. This rental rate should be equal to user cost or price of capital. This is a price from the perspective of owners. This is a price from the perspective of renters, right? Borrowers. Can you understand? So this one is same to this one. So rental rate of capital stock is R actually, same to this. This R is here in this cost function. Capital, look at this. The capital market is competitive, the rental rate should be equal to the user cost R. Why? Firms that own capital expect to earn a competitive return when they return it. This competitive return is the user cost of capital. Capital that is purchased can be treated as though it were rented at a rent rental rate equal to the user cost of capital. So user cost of capital is equal to rental rate of capital stock. Okay? And until now we explain what is this R, rental rate. Okay? Now, ISO cost line. Actually, we said this one, total cost curve, that is ISO cost line. Right? That is ISO cost line. ISO cost line graph showing all possible combinations of labor and capital that can be purchased for a given total cost. That is ISO cost line. Right? ISO cost line. To see what is the ISO cost line looks like, recall that the total cost of C of producing any particular output, Q bar, is given by the sum of the firm's labor cost WL plus each capital cost RK. So total cost is equal to WL plus RK. Right? So rewriting this, Y variable is capital, X variable is labor. Right? Then K equal C over R minus W over R L. Right? That is cost line or cost curve. Okay? So that is explained here. K equals C over R minus W over R L. It follows that ISO cost line has a slope. Right? Now, graphically, ISO cost line means X variable is L, X variable is L, Y variable is K, right? Then Y equal A minus BX type graph is needed. So this one is shaped like this. If L is equal to 0, K is equal to C over R, right? If K is equal to 0, then that is C over W, like this, okay? And this is this graph. And slope of this graph is W over R. Changing rate is minus W over R. Slope of ISO cost line is W over R. Okay, so the slope of changing K over changing L is equal to changing rate is equal to minus W over R, which is the ratio of wage rate to the rental cost of capital. So in other words, we can say relative wage rate, right? Wage rate in terms of rental rate, relative price of labor to capital. So relative wage rate, right? W over R. That is ISO cost line. So until now, we studied ISO cost line, originally this one. So we can rewrite like this, right? Featured by like this. Also, we can draw large of ISO cost line, right? Large of ISO cost line. All the ISO cost line have same slope, W over R, but different y-intercept. High intercept means, right? High intercept means C is total cost, isn't it? R is constant numbers because competitive market. So higher ISO cost line implies higher cost. Okay? So ISO cost line. So anyway, this cost minimization problem is simple. You want to produce, for example, certain amounts of labor, certain amount of pizza, for example. And this one is, we already studied the ISO quant, right? ISO quant is shaped like this. For example, like this. That is Q, L, K is Q bar. For example, 100 pizza. There are lots of labor and capital input mix to produce 100 pans of pizza, right? If you choose this one, right? Anyway, this one, you can cook 100 pans of pizza after combining, inputting this amount of labor and this amount of capital. Okay? If you produce 100 pans of pizza at this factor combination, L, labor employment, capital employment is this one, to cook 100 pans of pizza like this. There are lots of ways to cook 100 pans of pizza. right? That is subject, right? Meaning of this isoquant. And cost minimization problem said, anyway, you can cook 100 pence of pizza with cheapest cost, okay? Cheapest cost. So if you, now think about, if you choose this point to produce 100 pence of pizza, you hire this amount of labor, this amount of capital, like this. Then you can cook 100 pence of pizza, right? Then now think about, then what is the total cost at this point? You draw isocost line crossing this point. Then you know that you can draw this kind of blue isocost line, right? And y-intercept means total cost divided by r. As I said before, higher intercept means higher cost. Got it? Now how about this point? This point, this factor combination, labor and capital, result in 100 pence of pizza. But cost different from earlier point, right? So the cost, isocost line, crossing this point is this one. Okay? So compared to this point and this point, what happened? Total cost decrease, right? This way it continues. If you choose this point, you can draw this kind of isocost line. You can cook 100 pence of pizza with cheaper total cost than before, because isocost intercept of isocost line decrease and decrease and decrease. So in this way, we moving this way, cost for producing 100 pence of pizza decrease and decrease. Now we're starting from here. If you choose this point, this input mix, labor capital combination to cook 100 pence of pizza. But at this point, total cost is indicated by this isocost line, isn't it? Right? If you choose this point, total cost at this input mix is this one. Total cost decrease. So if you choose this point, total cost decrease again, because y-intercept decrease and decrease. In this way, we can find only one point to cook 100 pence of pizza with cheapest cost. That happen at this point. Okay? That is cost minimization problem, solution. At this point, we know that we can say that is L star, that is K star. There are lots of ways to cook 100 pence of pizza, but there is only one labor and capital input mix to cook 100 pence of pizza with cheapest cost. That is L star, K star. Can you understand? Now I'd like to explain this one using a slope condition. Slope condition. X variable is same, right? Y variable is change in K over change in L. In earlier chapter section, we already studied the isoquant, right? Slope of isoquant, that is MRTS. MRTS decrease and decrease and decrease, you moving this way, right? So that is MRTS, right? Marginal rate of technical substitution, right? And now think about slope of isocost line. That is W over R, isn't it? Changing rate minus W over R. Changing rate of slope of isocost line is this one, W over R. Okay? So at this input mix, what happened? Slope of isoquant equal to slope of isocost line, W over R. Right? So that is L star and K star. Can you understand? Right? So look at this. Production given output at a minimum cost. Isocost line curve describes the combination of input labor and capital input to production that costs the same amount of firm. Right? Isoquant curve is C1. Isocost curve C1 is tangent to the isoquant at Q1 at point A here. There are lots of isocost line, right? but at point A, two curves tangent with each other. Right? That is minimum cost to produce Q1 unit of pizza over the others. Right? That happens only you hire L1 among L1 or L star. Then total cost is WL star plus RK star. That is minimized total cost when you're producing this 100 pence of pizza. Right? Constant number, wage rate. Rental rate of capital stock is also constant numbers. And this, so as a solution of cost minimization problem, labor and capital decided. Okay, then you can calculate the minimized total cost. For example, other input combination, for example, L2 and K2. Where is L2 and K2? For example, here, right? L2 and K2. Then, so we can calculate cost of input labor, cost producing 100 pence of pizza at this point. That is equal to WL2 plus RK2. That is, for example, 10,000. Then calculation of this one means 15,000 like this. Okay? That point here, same happen. So we can find only one point, minimizing cost to produce 100 pence of pizza. That happened. From this original function, isocosine, isofund, tangent and minimize isocosine. Right? Two curves tangent with each other. That means slope of isoquant equal to slope of isocosine only at this point. Right? That is explained here. Now think about input substitution when an input price changes. Now input price changes, then what happens? Right? So originally this one, total cost line is this one or this one. Now wage rate increase. Rental rate of capital stock is constant, but wage rate increase. Then what happens? Slope increase. Okay, slope increase. Then you have to solve cost minimization problem again. The slope of new after wage rate, increasing wage rate may be like this. Isocost line steeper than before, like this. Right? Steeper than before. And you can find the new cost minimization point. That happened at here. Originally here, now here. Okay? So in simply talking, W over R increase, then what happened? Labor employment decrease, right? Capital employment increase compared to earlier optimal input mix, right? Capital increase. Then what happened? Labor over capital, labor to capital ratio decrease, or capital labor ratio increase. That kind of thing happens. It's a rational result, isn't it? Why? Wage rate, labor cost increase. So you want to produce same pizza, after hiring less labor and more capital. Okay? That is explained here. So substitution happens, labor and capital. Substitution happens between labor and capital. Right? When the price of labor increases, the isoquant curves become steeper. Steeper like this. Output Q1 is now, same output Q1 is now produced at point B on isocost curve C2 by using L2 units of labor and K2 units of capital. Capital employment increase and labor employment decrease because wage rate increase relatively and capital price decrease relatively. Okay? Recall that in our analysis of production technology, we should show that the marginal rate of technical substitution, MRTS, is the negative of slope of isoquant. MRTF is a negative of the changing rate. So something wrong, right? The negative of the changing rate of isoquant and is equal to ratio of marginal product. So MRTS is this one. We already studied this, right? That is equal to MRTS is equal to NPL over MPK. It follows that when a firm minimizes cost of producing a particular output, the following condition hold. MRTS equal to wage rate. Slope of isoquant should be equal to slope of isocost line. This one is equal to this one. When you're producing at A is optimal point, in left-hand side, what happens? MRTS higher than isocost line, right? And about at this point, MRTS is lower than slope of isocost line, right? This is lower than this one. Only at this point, equilibrium cost minimizing point, MRTS equal to W over R. That is explained here. Okay, so this one. So rewriting, so in some MR equilibrium condition, a cost minimization problem is W over R. Okay, you have to, when solving this cost minimization problem, to find optimal employment of labor and capital, or optimal labor demand and capital demand from the perspective firm, this condition should be satisfied, right? So, and we know this one is MPL over MPK. So rewriting this, MPL over W is equal to MPK over R, same thing, right? Okay, example, the effect of effluent fees on input choices. So X variable, what is X variable? So waste. Y variable capital stock. When the firm is not charged for dumping its wastewater, X variable is wastewater, Y variable is capital stock. So when there is no tax on wastewater, this one. So equilibrium, optimal input of wastewater and capital occurred at point A. But now, what happened? Government imposed an effluent fee, pollution fee. So using this wastewater expensive than before. So isocost line changes like this, right? So new optimal point, new optimal input mix of wastewater and capital moving to B. Okay, so use less wastewater and more capital. That happened after effluent fees imposed. Okay, then we go section 3, cost in the long run. I'd like to start this in 1 minute later.